Yes, yes, yeah. The word to you immediately. Okay, time to start again. Please take your seats. We could list up already some interesting issues to deal with, just in order to get the transformation that we aim at realized. Now, the theme is monitoring soil health. I give the floor to the moderator, Maria van Tapia, with new panelists, new presenters. The floor is yours.
So, good morning, and nice to see you all here. So we are now going to the second session today, which is about soil monitoring and also harmonization. And so we will have, first of all, this point of view from Europe, so from JRC, Panos Panagos, European Soil Observatory. And then we will have the results that we have obtained on this topic from AGP Soil, Working Package 6. And then we will have also an advisor from Lithuania that is here, which is advisoring on conservation agriculture. So I give first the floor to Panos Panagos, please. The presentation, please, from Panos.
Okay, good morning, everybody. I'm Panos Panagos. I'm working in the Joint Research Center, the EU Soil Observatory, and thank you very much, the organizers, for inviting me. Soil monitoring is a very hot topic, and it's really a headache. We have seen this also in the preparation of the soil monitoring law, also in the various revisions, and I hope that I can give you a flavor where we are and what we can do. So why we are here? We are here because we face serious issues with our soils in Europe, with soil degradation. Particularly, we have estimated that 60 to 70% of our soils are not in healthy condition. We have serious issues with soil erosion, as 1/4 of the soils are not in unsustainable rates. Of course, the cost of land degradation is estimated around, according to hard estimates, around 50 billion euros. We have issues of desertification in Southern Europe. Of course, the carbon losses from agricultural soils are quite high. And in addition to this, the issues with contaminated sites that have been identified. So based on this, and the European Commission is coming with an ambitious proposal of the EU Green Deal 2020, and we propose the EU soil strategy in November 21. The EU soil strategy is somehow a cross-cutting among different policies and different communications that have been issued in the EU Green Deal, like the Zero Pollution Action Plan, the circular economy, the chemical strategy, the Fit for 55, the climate adaptation, the Farm to Fork, and many others. But the important milestone is this one. 5th of July last year, the Commission proposed the first ever soil monitoring law, monitoring and resilience law, and where we are, just to give you an update on this. Of course, this law is the first proposal for a kind of harmonization on soil health in Europe, and puts in place a comprehensive and coherent monitoring framework, has a lot of emphasis in monitoring, and fosters a lot in sustainable management practices. Here you can see some building blocks. I mean, we have, during this process, we have tried to identify the objectives, to define what is soil health, a lot of discussions about definitions, criteria, indicators, etc., how we can do monitoring. A major issue was the soil contamination. And now the proposal has been voted positively, has taken a positive vote from the European Parliament last April. The European Parliament came with amended version. This amended version, of course, has a lot of emphasis in biological indicators and has given important feedback. But we have also done a lot of rounds with member states in the Council, and we have produced fortunately, we have the Belgian presidency who took the initiative and have discussed with the member states, and the presidency, I mean the European Council, comes with another amended version, and we hope that next Monday, 17th of June, this will take a positive vote from the European Council, and if this happens, then we have a kind of, let's say, 6 months, the two versions somehow to reach a kind of, the version of the European Parliament, the version of the Council, to reach a kind of consensus. We hope that we'll have the first step next Monday, and then of course we have a lot of work ahead, and we hope that with a common version, then we'll have 2 years of transposition in the member states, but we see a lot of interest from the member states, from the countries, on this monitoring law. So the countries are starting being prepared on how we get there. It's an important step for soil monitoring, and we hope that this gets through. In this context, the European Commission has established the European Soil Observatory in 2021, which has as a main objective to provide knowledge for soil policy, so to establish a EU soil monitoring system, to monitor soil health at European scale, of course, to have a stronger European soil data center, and of course, as a research institute, we do a lot of research and innovation and participate as well in the soil mission that I will refer later, plus to engage with the stakeholders through the stakeholder forum. You have seen many of our activities in the EU Soil Observatory, and you are also called to participate also in the stakeholder forum, plus in various working groups. Now I go to the hot topic, which has to do with soil monitoring. As you know, in the EU, the European Commission GRC has established practically the unique, let's say, harmonized system to monitor our soils, which is named LUCAS. So LUCAS is in place since 2009. Practically, it's a quite complex system because we have to design the points where the surveyors will go to train the surveyors. The surveyors should go there, collect the samples according to certain protocols, select a laboratory, do a laboratory analysis, make quality assessment, then from the point data to do these interesting maps that we have in the right. So we have done this for 4 campaigns, 2009, 2015, 2018, data are available, and now the 2022, 2023 was a little bit late, and now we go towards the laboratory analysis. In the last survey, we managed to reach, in the previous surveys, we had almost 20,000 points, but in the last survey, we managed to have almost 40,000 points. Of course, we have a huge archive in GRC that can be useful for various analysis. And now we also, in the context of the soil monitoring law, we target to have a lot of collaboration as well with the member states, because we know that the member states have similar data on this topic. So Lucas contributes to a EU-wide soil monitoring scheme because, as I said before, from the field, we get the soil properties like organic carbon, nitrogen, phosphorus, pesticides. And since Lucas is a kind of modular, we add more components of these like biodiversity and fungicides and a lot of new stuff. And based on artificial intelligence, machine learning models like Descent, Cubist, etc., GAM, we create those maps that have served quite a lot, both in the proposal of the soil monitoring law, but also in different other policies like the carbon certification removals, the zero pollution, etc., etc. So we'll speak a little bit about how Lucas can be seen as a EU-wide monitoring system. Is sufficient? I mean, it's a big question, and we have tried a lot. We don't oversell ourselves, like stating that Lucas is a EU-wide monitoring system, but at this moment is the only harmonized one. Of course, Lucas has many drawbacks, like we have taken only the topsoil 0 to 20 centimeters, but in the 22 survey, we have included the 0-30 centimeters sampling. Of course, there was missing a systematic bulk density, which was done partially in 2018 survey, but was enlarged in 2022. I'm speaking about soil organic carbon, which is a critical parameter here. We had limited, very important drawback, because we had limited information about management practices. I mean, we take the sample, but we don't know, even if we have included, we asked the surveyors to take information about management practices. Was quite impossible to compile a set of management practices that are applied in those points. So we don't have a clear picture if a tillage cover crop was applied there, because the surveyor may go in a period where the harvest has finished, where it's not possible to assess if it's reduced tillage or not. So through various pictures or remote sensing, we try to derive those information, but this is an additional step. And of course, Lucas was limited to 1,000 meters. I mean, we have no sums over the 2,000 meters altitude. So a step further, and in collaboration with EGP. So as you understand, the data harmonization is of paramount importance for soil monitoring, and in the context of the soil monitoring law, since we'll have legislation, we should be able to monitor better our soils. We know that member states follow different methodologies. They sample in different sounds, they analyze in different protocols, they have different analysis, let's say different sampling, soil property sampling and analysis protocols. And in Lucas 2022, there is an interesting exercise that is done with EGP soil. I mean, the sampling of Lucas has been repeated also by EGP and is analyzed by 13 member states laboratory. And the objective of this exercise, let's say like this, is somehow to develop these transfer functions. I mean, how can, there are two objectives in these transfer functions. Somehow not to lose the legacy data, because there is a lot of history behind. The member states have done a lot of surveys in the past, but also there are member states who would like to continue as they were doing in the past. They will not adapt immediately in the specification of the soil monitoring law. So somehow, in order to go from different systems, we should harmonize to one unique system, and this needs this kind of transfer functions. And this is a kind of headache for us that work in the interface between research and policy, how we can develop the best transfer functions that can be somehow non-biased and create this harmonized system. So I personally identify this topic as a hot topic also for further research, and we need somehow the community to come here with certain solutions. So regarding the EU Soil Observatory, what we have done in terms in support of the soil monitoring law, we have done a lot of stuff. Of course, we have supported the soil monitoring law. We have contributed to the impact assessment with the assessments that I showed you before. But I will speak about focusing in the stratified sampling. I mean, there are certain requirements from the countries as well. The requirements are to have, of course, to collect the samples which can be as much as representative as possible in terms of physical, chemical, biological properties. This is quite a huge, difficult puzzle. To maintain, of course, the accuracy, not to have smaller accuracy and high uncertainty, but of course to minimize the cost, because somebody can come and say, okay, it will be excellent if we have 2 million sums in Europe. Let's go and sum 2 million sums. Can we take it? Unfortunately, we'll have big resistance, because there are huge costs for analysis. We have followed before the discussion. I mean, is it possible with remote sensing to have soil properties? We are not yet mature to have this kind of, we need the soil sampling. So unfortunately, the costs are quite high. So what is done till now? The minimum sampling size by implementing the Bethel algorithm. I mean, in GRC, in the EU Soil Observatory, there was a geostatistician colleague who select, based on this algorithm, select the best points for the countries. has been sent to the countries in this period, has been tested with country representatives if the number of points can be representative for biological, physical, and chemical properties. And of course, we try to select the independent variables which are strongly correlated with pH, soil organic carbon, etc., which are the main parameters. So this is a work that already done, and this interaction will continue in the future and should be continued because we should test as much as possible if this stratified methodology can be enough representative. Of course, we operate the European Soil Data Center, and we move towards a new approach of the SDAC, I mean towards SDAC 2.0. In the first column, you can see that the SDAC has grown, geometrical during the last years. We host more than 120 blocks of data sets, thousands of maps, publications, etc., hugely accessed by all scientists. And in EU, we have more than 12,000 data downloads per year. Now we move towards SDAC 2.0, where we see the flows of data coming from the soil mission projects, the flows of data in the context of the soil monitoring laws. We start having this kind of collaboration with member states. The first pillar was a little bit of top-down approach. Now we'll have this interaction. And of course, we start having also the incorporation of products from other technological streams, like Copernicus. But of course, the general objective is to go towards 2030, having NASDAQ 3.0 or a soil health portal where we can update the indicators based on data coming from member states. And of course, this to be to host the data coming from the member states and to provide knowledge for policy. Of course, here the EGP is welcome to contribute to the soil data center, to EOSO. We have, in the context of soil mission, we have funded a specific project, SoilWise, which now develops a catalog for hosting all the data produced by soil mission projects, but this does not exclude other projects like EGP, like other horizon projects that can host and can somehow, we should keep this legacy for the future generations. So, as I said before, beyond 24, we want to accommodate all the data flows coming from the member states and the outcomes of the soil mission with enhanced functionality. Of course, here we'll speak about how we assess the soil health in EU. We have published 1 year ago the EU Soil Health Dashboard. Now, 1 week ago, we published an advanced version. And according to a convergence of evidence methodology, 19 indicators for 7 blocks of soil threats, we have estimated that 63% of soils in EU are not in healthy situation. Of course, this top-down approach, as I said before, is based on scientific evidence that we have collected through various assessments that we have done in the European Commission during the last 10 years. And of course, the dashboard shows different types of soil degradation process. This unhealthy soil does not mean that the soil is completely degraded or not be productive. Unhealthy soil can be be completely degraded or have a small issue that can be somehow reversed in order to mitigate it. So how was this developed? As I said before, we have estimated those 19 indicators grouped for 7 processes like soil erosion, salinization, high compaction, loss of organic matter, by the loss of biodiversity, loss of nutrients, soil pollution, etc. And based on soil degradation assessment that we have produced in the EU Soil Observatory, then we added some layers of aridity and vegetation degradation, groundwater decline, in order to develop a first assessment of land degradation in the EU. This was published a few weeks ago, and here our focus was mostly in agricultural soils, where we estimate that 18% of agricultural soils are not in healthy conditions, suffer of some of these degradation issues. Regarding soil organic carbon, in the context of soil monitoring, we have done an important assessment of trying to understand what is the trend of soil organic carbon. Since we had in place the 3 LUCAs, 2009, 2015, 2018, we did develop a data-driven approach, meaning that based on data, measured data on the field, to estimate how much carbon we gain or we lose. And based on this assessment, we see that 0.75% has been lost between 2009 and 2018, which is, of course, is around 70 million tons of carbon. Somebody can say not too much, but of course it's a loss. We see that the major, impact is due to land use change. I mean, when you have a change from grassland to cropland, we have a significant change in this trend. And of course, somehow somebody can argue if in these 10 years the climate conditions have played a role. I mean, what's the impact of increase of temperature or rainfall conditions? And you can see as well that the picture is quite is not homogeneous in Europe, because you have certain areas where you gain some carbon. You have most of the areas where you lose carbon. We have done also some novel assessments in soil biodiversity with Lucas, because we have a component, important component in soil biodiversity. Almost 1,000 samples are analyzed. And we have concluded that diversity increase with land use intensification. This doesn't mean that soil biodiversity is better when you have agricultural soils, but when you have more intense land use, of course, you have higher diversity. And increase in pathogens in agricultural soils, strong effect, of course, of soil properties on biodiversity, and pH is an important driver. Also, the climate conditions have played an important role there. Now, just to mention the importance of the soil mission, I mean, we have rolled out the mission 2021. Now we are in the 4th year. We started with 11 projects, 67 million euros in the first year. The last year in the work program, 135 million euros, 13 projects. There are a lot of projects on soil monitoring, many projects as well in carbon farming as well. So this is very, very important initiative from the European Commission. And of course, this somehow compiles this puzzle to understand where we are with soil protection in the EU. On the one side, on the green puzzle, you can see the legislation. I mean, the policy framework, which has to do with the EU soil strategy 2030, and the soil monitoring law, the proposal for the soil monitoring law. We, as EU Soil Observatory, we provide knowledge at the European scale. We support those policies, and of course, we have an important role in soil monitoring data and legacy repository. And at the end comes the soil mission, which is the funding mechanism for research, innovation, and knowledge. So this is the current situation in the EU on soil protection. And of course, we want to move from the top-down approach that we have implemented in GRC for the last 15 years to involve more the soil mission projects. So this is our vision for 2030. And of course, the Living Labs here will have an important role, because the Living Labs project starts now. And with the knowledge and data produced from the Living Labs and the indicators that can be advanced. I mean, I showed you before the dashboard. The dashboard is far from being perfect, but we expect the knowledge and the inputs from the soil mission projects to have a situation which somehow rewards all this investment of almost 1 billion euro in the EU. And of course, we should not forget the soil monitoring law, which at this point, at 2030, will be operational. Thank you very much for the attention.
Thanks a lot, Panos, for this wide presentation. I want just to comment, we do not have time for questions now, we will make at the end. I would like just to comment that we are very happy to say that our catalog, GP Soil, actually is the base for SoilWise catalog. So all the data set that we are currently collecting from GP Soil, from our national content center, data centers in the GP Soil countries, are already inside the GP Soil catalog, which is the base for SoilWise. So, and now I need the other presentation from us. Okay. Okay, the following slide. Next slide. Okay. Yeah, I will. Okay, so the content of this presentation are the results of what we have done in these 4 years. and some months more of GP Soil and Working Package 6, with also the collaboration of other internal projects. So we will speak about the comparison between Lucas and national soil monitoring systems, and also way forward to integrate the national soil monitoring system with Lucas. An activity about the selection of soil health indicators, and also setting threshold health targets and values. Then we will speak about the huge work done on the topic of standardization and metadata catalog collection, what I mentioned you, and also of production of a standard tool to exchange data sets in the INSPIRE model, so compliant with the INSPIRE model, and also linking to registries, so code lists of code lists and vocabularies. And at the end, also about new tools for soil monitoring with proximal and remote sensing. So all this huge work was done by several people, but we will present some of the core team. So my colleague Antonio Bispo from INRAE will start, and then Fanny van Egmond from Wageningen. So we will start with Antonio.
Thank you. Okay, I start with an exercise you already mentioned, Panos, about the comparison of data sets, but also of the networks. So I thank all the colleagues associated that work with us on that issue. So first we started at the beginning of EGP about the review of the existing monitoring networks in the different countries. And so we identify what you already said also, Panos, that several countries have monitoring networks in place for decades. And then and that Lucas Soil is the only unified protocol harmonized across EU. And we identify also several differences in sampling strategies, in land uses that are assessed, in sampling depths, in analytical methods, etc. And so the data sets are difficult to compare between countries, and even between countries and the Lucas soil. And so another point of that survey was we asked the countries if they were ready or not to adapt their systems and to change their systems. And well, mainly they said no, because it's installed for decades, as you said, Panos. And so the proposed ways to go forward were to first to compare for the different the national data sets with the Lucas data sets, because as you said, the only one unified is Lucas, so we need to compare to Lucas to have that kind of reference. And then we also try to compare the sampling and the analytical procedures in the countries and Lucas, taking the opportunity of the Lucas 2022 campaign. And also then to find ways to use and combine the national and the Lucas data sets to inform about soil health. And so first, the comparison of the national and the Lucas soil data sets. So we include more than 10 member states in that comparison. So we have the same protocol to compare the data sets. And so we compare the spatial distribution of all the sampling sites in the countries and in Lucas. And we saw that some countries and Lucas also may oversample or undersample different soil types or different land covers. And so this we can see here in that picture that here is the national median of here it's for carbon, and here it's for Lucas. And here you have the different land uses, the different depths, and the different countries that were in the exercise. And here it's the line the line 1.1. And you see that for certain land uses, it aligns quite well with Lucas, but for other land uses, forest, grasslands, for example, and different countries, we don't have a general trend, meaning that we have different assessments when you use the data, national data, or the Lucas data in the countries. And this can also we can also have an impact on the assessment of soil health. And here in that second figure, we compare the organic carbon to clay ratio for different countries while using the national data set or the Lucas data set. And then if we do that, in fact, we conclude different areas that are LC or not LC in the country. So this has an impact when we choose the network to assess the soil health. Well, this is a paper that is under revision. and we hope it will be published during the summer. You already talked also, Panos, about the double sampling exercise. So the countries, the Lucas sampler sent to the countries a sample. That sample will be also analyzed by EU, and then we will be able, we hope we will be able to compare the results, and so to draft those first transfer functions. And few countries also compare the sampling protocols, meaning the soil sampling protocols, because they are different between Lucas and the national. So we will have at the end, so when we will have the results from EU, we will be able to develop the transfer functions on the analytical methods, but also transfer functions that integrates also the sampling protocols of the countries. So that's the two first activities. And then third activities, mapping. In fact, you already said, Panos, that we have two situations now. We have the countries making their own maps with the national dataset, and we have EU, a top-down approach, making the maps with Lucas. And both informations are needed, are interesting, and so we are working on trying to integrate the two different kind of informations to produce new maps. So I can show you well, it's still a work in progress. And so what we see is that when you use Lucas Soil here, for example, we see border effects. When we use the national data, we also we have less border effects here, but we still increase the border effect elsewhere. So when we combine both, in fact, we decrease the border effects. So that's still a work in progress, but we hope to finish that this year. And second work in progress is to use the two data sets, not using the raw data, the original data, but convert those data into a score and try to combine those scores. And then the scoring, so we use different scoring functions that you maybe can see here. And using those scoring functions, you need to cluster, or you can do no clustering, because the scores are based on the distributions here. And you can use no clustering, or you can cluster according to land use, to soil type, to land use and soil type, and to land use, soil type, and climate. And I just show you here two figures where if you do no clustering, you still see differences between the national and the Lucas assessments. But if you cluster according to soil and land use, then the assessments are quite coherent. Both assessments are quite coherent. So we started that activity, and now we will try to involve other countries in using that procedure. So that's the first part of the talk, and the second was about the selection of soil indicators that we did in a deliverable 6.5 that was already mentioned this morning. And so I will not cite all the colleagues. Thank you for that huge job. And so we end with that kind of table as a summary, where in green here you have the indicators that are in the soil monitoring law, and more or less we all agree with those indicators. In red, that's the ones we are proposing that are not included or that are included but not with the same parameters in the soil monitoring law. And in orange here, you have here and here soil indicators that we agree, but we also want to improve those indicators. So for example, for soil organic carbon, we agree with the soil organic carbon content and soil organic carbon stocks, but we prefer not to have, in fact, the soil organic carbon clay ratio. And we want also to add new indicators, soil SOC, ratio with soil SOC X, no, C, max, and the other is the expected SOC, the second one. And also to add, for example, for biodiversity, other indicators, and I will come back to that just after. And so for SOC, at the end, we provide several tables with the indicators, and we compare, we give advice on the thresholds, on the frequency for measurement, on the period of sampling, the type of sampling, should we only consider topsoil or also subsoil, on the measurement methods, and we made a survey to to have the minimum costs in the different EU countries. So we also have an estimation of the cost of that indicator. So this is for SOC, for example, and we also did the same for biodiversity. And here you can, since the last modifications on the soil monitoring law, so now the soil biodiversity indicators change in the last version. And but we propose not to have them optional, but to have them, let's say, mandatory, to have at least 3 groups mandatory: the macrofauna, mesofauna, and also the microbial communities at a minimum. And with also an activity that is microbial respiration that was already in the soil monitoring directive. In that document, we also suggest other changes, like to adapt the frequency to the parameter, because up to now it's 5 to 6 years between each campaign in the soil monitoring law. Sometimes it's too short to see significant changes if we have no, of course, as you said, land use change. And not all the parameters, like contaminants, for example, need to be measured every 5 years. The sampling, we recommend also to sample not only topsoil, but also subsoil. And for the sampling, also to sample at field, of course, but also at basin scale, depending on the soil indicator for water, for example. And we also proposed proper sampling periods, like, for example, for biodiversity in spring or autumn, because you cannot sample during summer, for example. And also not to sample just after a management intervention, for example, pesticide application or tillage. But for that, of course, you will need to contact the owner to know when you do the treatment. So yeah, it's a difficulty if you do that. And we also try to sum all the indicators, the cost, to have the general cost, and it would be around between 1,000 and 2,500 euros per location. And finally, thanks to a work also led by Amanda, we try to develop an approach to set optimal target values or critical thresholds based on different options. I will not have time, but we can discuss that after. A fixed value or natural value or a distribution value or relative changes. We try to identify the pros and the cons of those options. And we also did an exercise for 3 countries, for Denmark, Italy, and France, using those different approaches and see the outcomes in the assessment of soil health. So again, this paper is under review. And I will let the floor to Fanny.
Okay, sorry. Yes, maybe if there is one question on, because we will pass through other very different topics. So if there is some urgent question now, otherwise I will give the floor to Fanny. No, it seems not. Yes, one there. On the back.
I'm Lorenzo Davino from CREA, Florence, and I would like to ask to Panagos, thank you for presentation. But what I think we have to think about if soil health can use a proxy like organic carbon or a traits like erosion, but cannot forget that soil life provides all the ecosystem services. And respiration and total biomass is not a measure of biodiversity, of course. And so I wonder that the results of in agro ecosystem, the result is diversity is higher than in forest. In my opinion, that is not true in ecological point of view. I think we have to have more ecological point of view and index, not only indicator, to assess the diversity of community. I work in soil fauna, but normally diversity in forests are higher than in agro ecosystem. Thank you.
Okay, thank you very much. Regarding the first part, of course, the approach that we followed was based on soil threats and the assessments that we had. Unfortunately, we don't have assessments, pan-European assessment on soil functions. I mean, you said before that, okay, yes, that we should assess in a different perspective. Of course, we should also assess from this perspective of soil functions as well, but we currently, there are little assessments or no assessments on soil functions in order to make a pan-European assessment of soil function. And to be honest, in the beginning, when we start having in discussing the soil monitoring law, this in the very beginning, 2021, we thought let's give a positive perspective and let's see from the soil function perspective. But unfortunately, we couldn't have any evidence. I mean, evidence means that at European scale, you should show to the policymakers where are your main problems. Regarding your second topic, I mean, we have done the assessment based on Lucas measured data, 1,000 samples, analyzed, of course, with certain methodologies. And based on laboratory analysis, 1,000 samples, as I said before, DNA analysis. I don't say that in agriculture soils you have higher biodiversity. You have, I mean, different, more diversity because you have a system that is more, let's say, treated, more in pressure. Of course, soil biodiversity is a new field. Somebody, as you are more expert than me, you can doubt about the soil biodiversity indicators. It's now that with this measured data, we should come with concrete solutions or with concrete responses to the policymakers. That's why we are doing this kind of research. That's my.
Okay.
Okay, so we now give the floor to Fanny.
Thanks a lot. I will now switch topic to data flows again. It was also already mentioned by Panos. How does data flow from the field basically up to the EU Soil Observatory in the framework of different directives and laws? Maybe before I start and get a little bit more technical, it already was mentioned several times, but there's so many aspects to harmonization. From the moment when you decide where to sample, so sampling design, then you go to the field. When do you sample? How do you sample? What is your protocol? How do you analyze the data? In which lab? With which method? How do you store the data? In which data model? Then how do you combine that data into a map, into a metric? And how do you then conclude? What does it mean? All those different aspects need to be addressed to make this system work. If we want to make a step towards integration of monitoring, all of those aspects need to be addressed. So that is, Antonio mentioned already quite a few of those topics. Many were also addressed by you also in identifying the challenges that we have. I'm now switching to the data model type. So how do we store our data? So after we've been to the field, we need to also understand what has been done in the field, which lab method have been applied. So how do you make sure that at the end of the line, when you want to integrate that data, you understand how it's come to be, and therefore how can you do that in a sensible manner? I realize we did not include a slide on that, so apologies to do that without a picture. I would like to talk a little bit about data flows and standardization, metadata catalog, and also on how do you exchange the actual data. So that goes to, I can only point to one screen, but if you look at the top figure, everyone starts with a data set, be it a project data set within EGP Soil, within an internal project, external project, work package, national data set, regional data set. Everyone starts with a data set. And that can be an Excel file, can be a database, can be a map, can be anything. That somehow, if you want to make it live, make it useful, you need to put it in a repository. That comes both the data, this is the continuous line, and also the metadata, so the data about the data that tell you how it's been collected. The repository is supposed to be persistent. It should last for 20 years, indefinite. And then from those repositories, national soil data sets that we've inventoried with EGP Soil, we did a massive stock take. So thank you everyone again for filling that in. And we also have a lot of EGP Soil results, but here you could also put in mission soil results or any other project results. When all of that is available and well documented, then the EU Soil Observatory can say, okay, this is available, and this is what we need for the soil health dashboard, or this is what we need to make the next best map. So if we all create that data ecosystem and that metadata ecosystem in a proper way, then it becomes a lot easier for us to do our research, for USO to report, for the CRCF to understand what can you use and what not. So that is basically the basics. We did several things. We did these stock takes that I already mentioned. So which data is available in countries at the national level, at the regional level. And then also we produced a lot of data within EGP soil that is now actually all coming in. So there's still a lot of data being collected that is being reported. And in the days before today, I also asked you, please make sure that you collect your metadata, that you register it, and we all collect that in a metadata catalog. So a metadata catalog is basically an overview where you can find whatever data is available with links to the actual data that is in a repository. So it's not one centralized database, but it provides an overview of everything that is there. And there you can edit your metadata. There you can find everything. And all of that will go to a repository in the end. USO can use it if they like. And also that set is already imported and that technique is already imported into SoilWise, this other project that was mentioned, which is also going to go to other projects and is also going to include knowledge. So not just data, but knowledge. And this is just about data sets. The link is over there. It's live. Please have a look. We also created guidance. So for everyone that thinks this is complicated, to some extent, but we really developed a lot of tools, a lot of guidance to make it easier, to make it manageable. We made a metadata template. So, okay, which fields should you fill? A standard database template, code list and vocabulary. So definitions on what do we mean with clay and can a computer understand that? And the geo package. And this seems to be pre-work, but the Inspire exchange standard was so complicated that a lot of countries did not implement. It was just too difficult. So we've done a lot of groundwork to allow data exchange going forward. So all of the Mission Sol projects can use this, SoilWise can use this, take it forward and then implement it to go and exchange. One of the things that we did is so that was on the metadata, on the data itself, you want to exchange that easily, but in a format that soil scientists can also work with. So you don't always need a programmer to do that for you. So we developed a geo package, which is a GIS type database. Let's put it like that, and that you can operate in any GIS system. That makes it really easy, but also complies to the rules and follows a model that Inspire provides for soil. That really allows you, so you can just basically take that file, send it to someone else, that someone can load it into their GIS system and have your data. So it's very, very easy going, and that we really think that that will help in providing data exchange between countries, between entities, and make it a lot easier. On the left-hand side here, you see a conceptual model. So first in Inspire, it's all defined how different aspects relate to each other. So how does a point relate to a profile, to a unit, to the lab method, to the operator, etc. All of that is already defined. What we did is translate that into that GeoPackage easy format. So anyone can use that on their personal computer or in an institute. There's a lot of guidance that comes with that and some quality checks also to make sure it's all valid. And it's been approved as an Inspire good practice. So it's also legal and okay to use. And actually those code lists and vocabulary, so these computer encoded definitions of what we mean with clay, with all these soil properties, soil standards, all of that is now also, you can just use that within that GeoPackage format. So it seemed maybe like a little bit of a pre-work, but now that is all easily digestible, all available, and can be implemented also in different ways for different users who need different types of software tools and applications. At the moment, the EEA already indicated that this is a very useful tool to exchange also data in their network with member states for the nitrate emission reporting. We think as EGP, as developers, so we are biased, I know that, that it might also be suitable for exchange in the context of the soil monitoring directive, but let's discuss. Oh yeah, and there's a lot of guidance developed as well. Videos, YouTube. Then to a really different topic on proximal and remote sensing. It was already mentioned by Geet this morning. so we've also had several projects within EGP that were looking at proximal, so on the go or below ground, anything within a couple of meters from the soil, and remote sensing that comes from satellites. I'm sure most of you are aware of the principles, but it's satellites looking at soil or surface. They retrieve a system, a signal back, and that tells you something about what is on that surface. That means that you only see the top, well, if you're lucky, centimeter. Some systems can look a little bit deeper, but this is something to realize. It's only seeing the top. So if there's a crop, you see the crop. If there's bare soil, you see the soil. But we wanted to explore how can you use that to also do soil analysis. Can you use that for the carbon, the CRCF, or can you use that for soil indicators? You can apply those techniques on all different kinds of platforms. There's different types of satellites which have a lot of precision or that just measure in a couple of broad bands. And that gives a lot of possibilities. And they come with pros and cons. So just to go, why would you start doing this in the first place? Well, it is very cost effective. The prices, when you look at proximal soil sensing, when done well, is probably 1/3 of the normal lab price. Then a lot more samples become interesting, which means that you have a lot more data points and maybe a better representation of your land use type or your soil type or your soil unit or your soil district than you could have otherwise. You can, with one measurement, you can measure a lot of soil properties in one go. So that is also very interesting. Prices have dropped because of that as well. It's very fast. It's non-destructive, so you can do it again. It's reproducible. You can deduce how it's been done. It fits on different platforms, lab, field, remote, and you have this aerial coverage, especially if you go to aerial or remote. So you can do mapping and you can identify patterns across a field and make it quantitative. And a lot of protocols are in development, and we've worked on that in EGP as well. There are a couple of downsides, and I would like to mention, because sometimes this is really mentioned as like the silver bullet and the solution to everything. And I'm working in sensing for 2 decades now. I'm really convinced of the technique, but there are some downsides, and we should be honest about that, and we should communicate about that. That's why it's on screen. Clouds are a problem, which is especially for the northern countries quite a challenge to get an image of what you actually want to see at the right moment, at the right time. It's very basic, but it is a problem. Vegetation cover, we're going to regenerative agriculture, cover cropping, and I'm all in favor of cover cropping. The only thing is you don't see the soil anymore from a satellite, so that's a little bit of a downside. When you go to the in-field techniques, you cannot control all of the factors that make a spectrum, so the visible near infrared spectrum that you measure, make it worse. So you have noise, moisture, roughness, dry vegetation, salinity, they all affect the signal and therefore the quality of the result. So that is a problem. I already mentioned the penetration depth, and you always need to calibrate it to the actual soil properties. So you always will need some wet chemistry, some traditional lab methods. You cannot not do traditional lab methods. This is a tool that helps, but that's it. And the accuracy also differs depending on the platform and depending on the type of instrument that you use. So there is a cascade there, and we can quantify it where I actually wanted to give you numbers, but there's so many factors that would turn into a really long story. So I left that out. Also, the model performance varies per soil property and also on your calibration set, of course. So depending on the application that you have in mind, it might not be suitable. And that is good to realize. Well, what we did in EGP is to really work on those methodologies. Can we correct for those disturbing factors that really degrade the signal? And the answer is yes, to some extent we can. So we did develop a field protocol that really improves for proximal sensing in the field. Also mathematical corrections, both for remote and for in the field. So there are advances. We're also evaluating the cost and accuracy of all the different methods, from very simple interpolation from lab results up to normal, like inverse distance weighing or other interpolations, to using satellites, to using proximal soil sensors or combinations of that. What does that mean for your cost and accuracy at the field level? So we did literature research, we asked companies, and we also are doing a test, actual test with data on 13 countries. We also tested if you develop a model between all those sensors and soil data on one location, can you then extrapolate that to others? How well does that work? What is your error? Because that would save a lot of cost as well. And yes, depending on a couple of constraints, that can work, but you need to think about what you're doing. This is my last slide. So there are a couple of applications for which remote and proximal sensing can be a solution. Vegetation patterns works very well. Vegetation identification, what is growing, works very well. Biomass estimation, digital soil mapping. So using it as a pattern to then make your digital soil map, like was on screen by Antonio. Smart sampling, using the patterns to choose where you go and sample and how can you diminish the number of points that you need. Within field patterns to communicate with farmers how to do, where to do what and why. If you have bigger differences in soil and some of the soil management, you can also see. Some things are difficult and are not possible at the moment. Direct estimation is challenging. For carbon changes detection, I would not go there at the moment. Soil management detection, working on it. So some of the other topics we're still working on it, and we think it's useful in the context of these two directives, regulations. But really think about physics, think about what you're doing and how it can help in a good way. That was it.
Thanks a lot, Fanny. It was a lot of information. I hope you are still alive. And yes, I want to tell you that we also have done several webinars on these topics, and we are going to produce much more capacity building because this topic of soil data is very wide, and there are a lot of things to be done to make also soil scientists capable of this topic, quite difficult one. And now I invite our Lithuanian colleague, Tautvydas Beinoras, right? So he's an advisor on conservation agriculture, and I will give you the floor. The next presentation. Thanks.
Good afternoon, everyone. I am Tautvydas Beinoras. I'm Lithuanian, and you are welcome, everyone, to Lithuania. I hope you find interesting Vilnius, especially, and really very nice to see you all of you. And I first of all, I am an agronomist, and will give my point of view to the things, to the soil, to what we are talking about today. First of all, thank you very much to one who presented already, who's presented, shared the information, very interesting really, and very useful. From my point of view, as I said, first of all, I'm an agronomist. I'm not a scientist like you all probably. And I will give a little bit different point, slightly different to the soil, how I understand. And I'm in agriculture from 1993, directly involved in farming in big company. At that moment was the biggest company in Lithuania. I just joined Canadian-Lithuanian was and started in 1992. And I've been working almost for 30 years, now not in this company already because it changed, it's became an organic. And now I am independent consultant. And really I see the soil, first of all, like it, as we talked about soil health, and I understand soil is alive, first of all. And looking at the soil, how to human, and and then I can deal to talk to the people looking at the soil, but it's really alive. What it means alive soil, and what it means health soil, from my understanding. In the soil lives a lot of microorganisms, and the soil is their home. And first of all, my understanding, we must care, like farmers, must care about this house of these microelements, microorganisms. Sorry, and they live, they create, they do everything. If they couldn't have them in the soil, soil would be empty. It would be dirt, it would be sand. Even in sand we can find them. And my understanding today, really, what we have with the soil, it's connected directly with to the microorganisms and their activity in the soil. That's why what was presented, what is healthy soil, what we must do, okay, understand with other things, chemical, physical activities, what we look like. You are a scientist, you are looking at the exact points, you need answers. And me, I'm more like consultant, like agronomist, I'm a little more flexible. So how in that point, I'm not directly, not strictly need answers to say yes or no. I can philosophy a little bit in agriculture to understand and not going away from scientists. That's very much thankful to the scientists what we do. But sometimes I understand that scientists, they are looking very narrow in some things, each one in their direction, what we are asked to do or what we really do. But we are missing sometimes this general view to the soil and to the all things what is happening in the soil. And really a little bit my story, how I came to this understanding. As I said, I in agriculture directly involved was from 1993. And in the beginning, we've been working, I was in direct farming, we've been plowing technology on our farm. Later was min-till, you understand, without plow. And at the end, we already in 2017, we've been already in no-till, going in that direction. And was decision made from owners. They sold the company and we became an organic farm. Biggest one farm in Lithuania and in Europe, Auga Group. We joined in this group. And I was really looking each time. I was an agronomist, as I said. I was responsible for the later was farm production director, and was each time involved in this understanding. Why we been changing from plowing to min-till to no-till? Because of inputs, because of profit, because of we need the changes, not because of somebody told to us, but because of we understood we cannot go forward like that because it's already we are not getting profits. Also, to be honest, each farmer working for the profit first of all. Later they will think about how to be very in good relations with the nature, how to save everything what we are talking about. I understand this is connected. Today I see everything is connected. We are part, like a farmers, we are part of this game, big game, and we very much dependent on soil, like our farmers. And really very, very problematical in Lithuania. I cannot say what is in other EU countries, but in Lithuania, farmers cannot understand, honestly, too much. We are not, few of them, honestly, by percentage, very little, who starts to understand what profit, not the main reason for what we are working for. They, as I understood, without profit, you cannot continue your business. Of course, it's understandable, but to become like I'm very not a little bit against what farmers are saying. We are businessmen. If they say like that, they not much take care about the soil because money is the main reason for what we are working for. That's why really my understanding today. And I, as I said, I went through these different technologies and been changing because of needed. We need to manage our expenses, and plus not to lose the yield. And that's once I remember why we changed to min-till. Plowing was expensive system. We've been putting more chemicals, a lot of fertilizers, and at the end we needed to do something. Prices was for the grain, I remember, sometimes was very down, sometimes up, and you cannot predict what will be next year because we are on big market. Farmers cannot control the grain prices, we cannot control fertilizers prices, we cannot control chemical prices, everything. But what we can control, we can control our expenses, our works on soil. How to prepare the soil, or to min-till or no-till to go evenly. This we can control. And I'm also now like consultant. I'm consulting the farmers. We really must concentrate to the soil, concentrate to the soil. Today maybe will be this transition period from one system to another. For example, it can be costly, and some farmers really honestly we are afraid what will be if we are not to succeed in this. We will lose money, we will lose something. But I am saying to them, if you are happy today with what you are doing, you don't need any changes somehow. People will start do changes, then we will want themselves. If they do not want, I like consultant, I can't say anything. Even the EU politic, what we are now, Green Deal, everything, it looks like it pushed from up to the farmers, and they are very much against because they do not understand really these rules, these regulations, what was presented today. Ask if farmers will be asked to make soil sampling, as we saw, very costly. Farmers will not be able to pay this money. Really, if will be somehow some programs, if will help from EU somehow to some funds to support them, then we will be okay. Maybe will be way forward. I am not against this, honestly. My understanding today, I am very against. I think that soil is the most thing, and we must to how to start to start. Do we need changes? First of all, I said it's we've been pushed by our economy, but we must understand to make any changes on EU level. We must understand, and I understood today, we must understand where we are today. On what basis we are working. If to look to the soil, I was also honestly involved a little bit in this soil project. What was comparing on Lithuanian level, comparing what soils are in other countries, how we can compare between EU countries, and I understood maybe. Well, it's task for scientists to do this, but for the farmers, they don't care really how you will measure, how you will do. They care about if it's somebody will say, and I here see very big role of consultants, independent consultants, not companies, not chemical companies, not big who are related with some chemicals behind, but independent consultants. The aim and to say exactly, to say ways, to show the ways how can be done, how in this way, and farmer must have possibility to choose which way to go forward, and to understand and how to change this. As I said, everything is in our heads and in farmers' heads. If they are not ready for changes, they will not do. If they will be pushed, they will be with tractors out to the streets, like what is happening in the EU, and because they do not understand. And here I see very big role of knowledge, somehow how to give this good knowledges. That's why I am very happy I saw this EU projects, living labs. What is very important somehow to understand and to show to the people different ways. I said, you are here today, and this way you can go forward. You can choose, it's expenses like that, expenses, your profits will be like that, not incomes, but profit. Many people now are talking about income will be, I will lose income, but I say, you must calculate your profit, because income doesn't mean anything. If it's high expenses and high incomes, profits can be very little, very low. And that's why, okay, we must calculate our profits. And really, we live because of profits. You can invest everything to do and go forward. And maybe not to go very details, as I see really with presentation, how to react, as I said. Okay, it's a very good thing from my point of view, but for the farmers if will be farmers pushed to pay for this and will be pushed to take the soil samples, they will be against. This is normal. It's not only Lithuanian, I think. It's in all farmers, in all countries, will be the same. They will be against somehow. And some to help if state wants. What is state? It's not only farmers, all people. If all people wish for good food, they will be asked farmers for nutrient-rich food. Okay, they will produce. Farmers will do if we'll see it's economically useful. But if it's not for them, if it will be more rules, more some bigger, higher tasks for them, we will be against, because people are different.
Okay.
And yeah, thank you.
And I really thanks for this inspiring talk by our advisor, which is really linked to farmers or to the perception of farmers. Actually, I really also support what you said. We have done a similar research in Sicily with Edoardo Costantini. We found exactly the same, that the farmers are not stick to increase yield by itself, but increase profit, which means to the balance between the input and output cost should be increasing, so having more profit for the farm. So, and this is a great insight that you give to us. So, because we have several indicators. One of these is also increased productivity. But if you increase productivity with more cost and with losing fertility, this is not profitable at all. So, so I really thank you for this, and I would like to call our panelists to take a seat. And you also. So I know that we have also a very important question online, so I will ask you to be very concise in answering. Otherwise, we will not have time for a question from the audience and also from online people. But I would like to have a round from our panelists just to give some answer to what you have heard from our consultant in terms of, for example, the perception of indicators, and also about this concern about why we are monitoring. They just want to see profit, so why monitoring soil health? And what do you mean for reasoning what is a soil, healthy soil? I know the farmers really stick to have fertile soil, so productive soil. So, and he also said that an interesting thing that is that soil is alive. So he also know that the soil, farmers know that a soil alive have also, I mean, biodiversity inside. So, but just an insight to you, how could you answer to our advisor from Lithuania? So you, yeah. I mean, please be not take too much time, because we have only 15 minutes to the end of the session.
It's true that when communications come top down without being explained, sometimes we may have these negative reactions. That's why we should explain very well what's going on. But you cannot ignore the evidence. Evidence means that in certain parts of Europe, maybe you are lucky, but I'm coming from Thessaly. I'm son of farmer. I have a big farm as well. And I have seen the difference during the last 30 years in Thessaly, in Greece. I mean, soils are degraded because they have been under intensive agriculture with a lot of, let's say, nutrient inputs which were not needed. A lot of, I mean, with not properly managed high erosion rates and very low organic carbon, less than 1%. So we can understand the situation there. And then the farmers are coming to me and say, Pans, why we are coming? I mean, we lose productivity and we have to put more fertilizers because the soils are not productive. And of course, if you see the history back, this is the reason. Because the last 30 years, we followed unsustainable management practices. But we haven't communicated properly what is going on. And now the floods came last September, and at the end, everything is almost in a very destroyed situation. So this is my first point, that we haven't communicated during the last 30 years what is going on, why soils are degraded. Now we have a better understanding, of course, but maybe our messages do not reach you very, very well. Also depends on certain areas of Europe. Regarding the costs, very important question, because, okay, Lucas, you can imagine, I'm also having Christian here. If we haven't Lucas, we couldn't have even a proposal for soil monitoring law, because we couldn't understand where we are. Well done or bad done, with Lucas, we are able to see where we are, more or less, what is the current situation. But without having Lucas and proper baselines to show where we are, we couldn't state, I mean, what we want to go. So Lucas, fortunately, the cost of Lucas were not so high. I mean, it's almost 1 million euro for the analysis. I don't remember, more or less, for the surveyors, but we speak about, in general, for what it has offered to science, to policy, to the farmers, to knowledge, I mean, the investment has paid back many times. Now, there's a big discussion on the soil monitoring law. For example, okay, Lucas, we have 20,000 sums and cost, let's say 5 million euro. If we go for 200,000 sums, there the member states are coming and they say, okay, this will cost in total in the union around 100 million euros. We can imagine that a small country like Greece, it may be 2-3 million euro. To me, 2-3 million euro is just, I have the theory of the roundabout. It's just two roundabouts. It's an investment of a roundabout. So it's the cost of investment, of such investment, of monitoring the soils and having a good knowledge of your soils is really peanuts compared to what knowledge you will get.
Okay.
And I hope that this of course, it will not be the farmer cost, but the results of those analyses have to be communicated to the farmers regularly in order to have the knowledge of what's going on.
Okay, thank you. Fanny, very short.
Yeah.
I have understood that you taught Vidas as a representative of conservation agriculture, sorry, is something else than some other farmers if I look at the monitoring. Fanny, what do you want to say?
I think I've worked many years in precision agriculture, and there it's the same thing. So only if farmers see the benefit, then they will take it up. So it should come from bottom up, and otherwise we should not care. And we should be very clear and do independent research on what works where and where it does not work. For data exchange, very briefly, a lot of data is collected, and a lot of people will want access to farmers' fields to understand what is going on. But very often, the data is then communicated back in a way that is not useful for farmers. So what's in it for a farmer? How can we combine all these different data sources in a very efficient way to serve EU level, research level, farmer level, national level? How can we do that in a smarter way is, I think, a very big challenge that we should address together. And we
Okay.
need to communicate for that.
Okay, so yeah, monitoring data are used for different levels, different purposes, and we try to combine that. May I already say what Mirko writes, Mirko Barbero from DG Environment in the online meeting. How nice results, thank you very much, Antonio and Fanny. But how could the soil monitoring legislative process digest and take this new knowledge into account adequately in the limited time left? I think, honestly, that it is a question for GRC first. No? For who? For Antonio?
No, I can answer that. We prepared, for example, we help in the implementation because
Are
as
we in
said,
time? Are we in time to,
yeah,
to integrate our new data?
I think we will because as it was said by Panos, the for the transposition they give the GRC give us the script, for example, to test the number of samples, and we GRC help and also the EGP colleagues we help different countries to test the script and see how many samples they will need to monitor soils, and then what we did we tried. Maybe it's not enough, but we try to draft several policy briefs about the monitoring, we are drafting one now about the transfer functions. We are finishing one on the soil biological indicators. So I think, yeah, we try to simplify the messages.
So
maybe it's not enough, but
there are contacts between you and the policy level.
yes, yeah.
They know already about the results.
We had several meetings with DG Environment to show the progress of the
so
GP.
Can we reassure Mirko Barbero that you are not too late?
I hope so.
Okay, can I also, yes. I think that the one of the key points of the GPSOL are the national hubs. So we are not working alone. We are fully in contact with people who is in charge of taking connection in the correction of the proposal. And so why we were commenting the first version of the soil monitoring law directive, we were it was a process. So several of these suggestions that we have shown to you in the deliverable 6.5 actually have been taken already in the revision of the soil monitoring law directive. So we are very proud and happy to have this interaction.
Okay.
And for sure, I think that since we know that after the first year of implementation, it was foreseen that there could be some kind of adjustment. And so we will further adjust in the
Okay.
following years, I suppose.
Okay.
And
Okay.
as an example, we push with the Monitor project and the World Package 6 to try to push for the biological indicators. And in the last
Yeah.
version, they were implemented also. They were, and then that's something you already said, that soil is alive, and that
Yes.
we need to monitor not only the house, meaning the structure of the soil and the physical
No.
chemical parameters, but also the living organisms.
Okay.
May I ask, or advisor, when you make a consulting, when you go to the farmers, what kind of analysis you do?
No, it depends on farmer. If some farmers ask for that, in Lithuania not possible to do, we're sending samples to abroad. And some farmers, really few of them who are interested in this and really we asking for this analysis. We do themselves. Really. I'm not taking that. I'm just my really opinion to a little bit to continue. Really what I understand, honestly, I see the future of the farming. If I would be a farmer today, I would go away from chemicals completely, away from mineral fertilizers completely. Even in the nitrogen fertilizers, we can find another ways how to. But it's just maybe I'm alone thinking like that. But I really believe in this because from my experience, what I found and what really I saw from other people in the world, in America and Australia, a lot of people talking about farmers. Farmers are talking what they are sharing experience and really understand what we can go. And most important is to have this alive, healthy soil.
Yes.
Most important.
I hear you say that your advices are experience-based, not necessarily monitoring or measure-based, but your experience says my advice will be the right one.
Everything is connected. To understand honestly, not only this, what I'm saying, really, people, as I said, asking first of all, do you ready for changes? If they want to change themselves, if they are ready to already, then I can recommend something new, different, But I understood in the beginning, some years ago, I was really very somehow enthusiastic. I will change the world, but I understood people are not ready. Not ready for changes.
Okay.
They must first of all to understand what is a live soil, how we can deal with the soil, in proper way, and we will be less dependent on chemicals, fertilizers.
Okay.
This is important.
Very convincing. Thank you. I think one last question or remark or suggestion. We have 5 minutes left.
Thank you. My name is Victor Castillo. I have a question to Panos. Hey, Panos. The question is, how do you integrate national information in your European scale assessment, like soil erosion, soil organic carbon losses? If you have made any progress in analyzing how well match this kind of top-down information with national information in any case? Thank you.
Thank you. As I said before, what we presented in the dashboard in various assessments are top-down assessments done at European scale, using Lucas and then using advanced machine learning models. Of course, when we do the assessments, we don't ignore what's going down in the ground. I mean, we compare with national assessments or national studies, and we want to be sure as much as possible that what we produce is somehow correct. But in order to reach this kind of indirect comparison, but in order to reach a kind of perfection, the way forward is this kind of, let's say, harmonization that I have proposed. And the harmonization should take place since the member states, since the countries will not change their monitoring schemes, and it's right not to change the monitoring scheme because you have there for a long time. Is this the key point? Is this transfer functions? I mean, how we'll be able to harmonize the Lucas data which we have done with certain depth, certain protocols analyzed by certain laboratory with national data which are analyzed by different laboratories, different protocols, different depths. That's why we need this kind of transfer function. And we need to work a lot on this. Of course, EGP started, and it's much appreciated. And of course, we need much research on this in order to be able to transfer all this knowledge at European scale.
Okay, an additional answer from Fanny, and maybe the last one.
Yeah, just to build on this, so this sampling design exercise that we did, one key point of the algorithm that is now proposed is that existing monitoring systems, the locations of those, can be integrated. So you take the Lucas sample as it is now, you take the national design as it is now, and then you apply the algorithm to understand where you need to go additionally. So
This is what
a very
needs to be done, or is it already in process?
this is done. So we worked together with the RC colleagues to evaluate the script with the best used decisions that we have, and we worked with a lot of you guys here in the room, and it was an amazing exercise of how science and policy work comes together. So maybe just to add also on Mirko's reflection, the implementation is still ahead of us. So now this is the bones and the structure of the directive. It needs to be transposed, it needs to be implemented. So a lot of the detailing still is to come. A lot of
But
more
building
detailed
blocks are there.
The building blocks are
there.
there, yes, but all of the information that we've presented,
Okay.
and we left out a lot,
Okay.
that can be used in those guidelines. And I think a lot of the people here are advising their national representatives in the council, in parliament, with what they can offer, learning from EGP, bringing that to policy into that implementation phase, and that will be crucial. And unfortunately, EGP will be finished by that
Yes.
time. But it's really amazing to see how the timelines of this policy development and EGP as a research and the mission soil have come together, because I think actually that's quite unique.
Yes.
How that is aligned and how we can therefore also really try to support.
Thank you
policy.
so much for this explanation. Maria, can you please conclude? It is time to go
Yes.
for some food.
Yeah, sure. We are, I mean, we love, so we could stay much more time speaking, but I understand we are very, very tired also. And so I really thank all of you. And also I want to thank, as Penny say, all the colleagues, an amount of colleagues from the partners that collaborate in our activities of Working Package 6 and other connected internal projects. And thanks a lot.
Thank you. At a 1:45 to